So we have alkali metals. Alkali metals are the group 1 metals. Okay, so group 1 metals, we have lithium, sodium, potassium, rubidium, blah, 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 blah. So many of them. Okay, so they are called alkali metals, because they will react with water and form alkalis, whatever you call it. So you have in the image, you have like 5 of them. Okay, so they are all silvery in color, and most of them you have to keep them in a sealed container under oil. They they cannot be left on the table because they are very reactive metals. They may burn in oxygen, or they may react with water in the air, and you will get something that is quite unmanageable. So you have to put it in a container filled with oil. So then these metals are very different from the rest of the metals in the periodic table, and also different from the group 2 metals. They have very low density, but you will see that the density increase as we go down the group. So then you see this
Sodium and potassium flux, rhodium
rubidium
6.
will sink. So see, like the image I put down there, they say water has a density of 1. So and anything which is lower than 1 will float. So lithium will probably be like this. Then potassium would probably be floating in like that. Okay, no. Sodium, potassium will float like that. Lithium will be like this. Something like that. Then after that, if it's rubidium, you'll be rubidium under like that. Something like that. And this water has a density of 1. Then anything with low density floats. This thing is also in physics, so you have to know it. Then they are very soft and they can be cut with a knife. The one on top is sodium, the one below is lithium. Then you will notice you notice to the cut surface. You check the cut surface. So once you cut it, it's very shiny. Then after that, it immediately change color. That means it immediately reacts with air. So when it reacts with air, the color will change and it doesn't look as shiny as before. Then you see lithium. Lithium doesn't change color that quickly. So that means lithium is less reactive than sodium. If you can conclude, I mean, a simple conclusion, a very basic kind of conclusion. Okay, then you have melting boiling point. You see those metals are relatively soft, and you can go back, you see this is almost like liquidy form, the last two here. Almost, there's still a piece down here, but it doesn't look as solid as the rest. So you see the melting point of lithium, sodium, potassium, rubidium, right, decreases down the group. The boiling point also decreases down the group. So these are also characteristics, very characteristic of group 1 metals. Other group metals, right, like group 2 metals, transition metal, they all have high melting and boiling point, just different. So they are good electrical and heat conductors. So how they conduct electricity is like in the diagram. So you remember their atomic structure, the electronic structure, then you will have one valence electron. So what happened is, right, these valence electrons, right, they are weakly connected to the nucleus, so they can move. So if you connect a battery, the electrons will move, and then they will move around. So then it conducts electricity. You just need to know this. The explanation, I don't think you need to know. So then heat conductivity is the same because the electrons move. And if you go back to physics, they say you have the heat transfer via the free electron, mobile electrons. So that is similar. The explanation is similar to that. So what you need to know here, take away from here, is group 1 metals are good conductors of heat and electricity. Anything underneath the lengthy explanation, that one is for your own understanding, for your own interest only. So this is a summary of whatever points you have on it. Then we come to chemical properties. Chemical properties just means that what kind of chemical reactions the alkali metal go through. And the type of reactions, the type of chemical property depends on how their similar electronic configuration. So if everyone has one valence, the metals with one valence will react similarly. So that means lithium has one valence here, then sodium one valence, potassium one valence. They will all lose that one electron to gain a stable noble gas structure. So the kind of reaction they will have is almost the same also. So if lithium reacts with water, then very likely sodium also react with water and potassium also react with water. So this is what they mean by we have similar properties. Now, so just now I said they have to be kept under oil. Okay. So group 1 metals, they are very reactive. They react with air and they react vigorously with water also. So they are kept under oil to prevent them from coming into contact with air and water. If you search YouTube, you will find a few videos of them reacting with water, and from rubidium, cesium onwards, the reaction can be quite explosive. You can go and find it. So this is a summary as well. So more details down here, more chemical equations. Yeah, so metal will react with cold water. The group 1 metal will react with cold water to form metal hydroxide and hydrogen. And this metal hydroxide is soluble. You know, your soluble spa compound. So you see here, lithium will react quickly and they will float on water. Then you don't see any flame color. Then sodium will react quickly. Then you will see this, and then you will see the sodium floating around and moving around the surface. I will show you the video next time. Then potassium reacts violently, and then this has purple flame. This one yellow flame. This one purple flame. So the whole takeaway here is, here the first line reacts quickly. Second one reacts very quickly. Third one reacts violently. So going down the group, the reaction become more vigorous. So in this chart, you take away that conclusion and you take away what kind of reaction, what kind of product you have, which is here, and they expect you to know how to write this. They expect you to know how to write the chemical equation. Then this one, you see a star here. I'm going to skip. There's this question, why does the reactivity of the alkali metal increase down the group? You remember this one, then I say you take away this. You take away this fact. So this is the explanation. Okay. I will let you read this first for 1 minute, then we explain this. There's a lot of words on there. From bonding, you understand that bonding means there's a chemical reaction taking place, right?
Yeah.
Okay, so we have that. And then why bonding happens is because you want a stable electronic structure. Am I right? So now we have group 1 atoms here. So let's say lithium. Then lithium has this electronic structure and it has one valence electron out here. So for a reaction to take place for group 1 metals, what happens is it will lose the valence and then form a positive ion, right? Bonding happens when group 1 metals loses its valence electron to form a positive ion, right? So then in that case, right, every group 1 metal will have to lose one electron in the valence shell, correct?
Yeah.
Okay. Then next, then how you know, okay, whether it is more reactive or not means how fast it lose the electron. So more reactive means it loses valence electron more easily. So a metal is considered more reactive if it loses its valence electrons more quickly. Can? So Then what these two diagrams says is like this. Lithium is a small atom. Potassium is a bigger atom. So it is easier for lithium to lose the valence electron. Now it's less, okay, it's easier for potassium to lose this valence electron as compared to lithium. So the bigger the atom, the easier it is to lose the electron. So then it is more reactive. That's why going down the group, the atom becomes bigger, it becomes more and more reactive. Do I make sense?
Yeah.
Okay. So the words I use down here, right, are sufficient for you to lift and put it into an answer if they ask this question. I try to put all on all my slides. You can lift off most of them and put it in your answer if you have a structured question. I may miss some words here and there, but I try as much as possible, as close as possible to for you to live. So this is a summary. So from melting point in decreases down the group, density increases down the group. Is it so? Yes, it is because down the group it sinks, and the reactivity increases down the group. And question. You can live. I said I try to put it as close as possible for you to live. Distinguish. State 3 physical properties which can distinguish group 1 elements from other metals. You can get the answers in the notes. Distinguish, that means tell apart. You can tell apart group 1 from others. Tell apart, that means they are looking for differences. So it is a good conductor of heat and electricity, and other metals is also a good conductor of heat and electricity. So it is not a difference. Yes, this is one. Something else, you got 3 of them. So one is melting point, then there are other 2 physical properties. Yes, they can be cut with a knife. One last one. This one, you can say that they have low densities. You say this one, third one, you say that they have group 1 metals have low density. Because the other one you say is softer, then they have low melting and boiling point compared to others. So this one, they have low density compared to other metals. Okay? So if soft can be cut by a knife, then they're low density, they have low melting point. Okay, then now this one. State 4 important trends down the group for group 1 elements. 2 more. Need help?
Yeah.
Let's see what's the answer. You are missing out on this. Increase in size of atoms.
Oh.
Yeah, and I show you the picture some more right just now. See, I show you the picture some more. Question 2. A metal P in group 1, metal P in group 1 of the periodic table would be expected to A. React vigorously with water, B. Form acidic oxide, C. Form amphoteric oxide, and D. Form an insoluble salt with sulfate ion. React vigorously with water. A is correct. Question 3. Which is likely to be a property of francium?
Yeah.
Okay, so first, you need to know the properties of group 1 metals. So group 1 metals, the properties, the summary will be here. Physical properties of group 1 metal. So they change gradually down the group. So density increases down the group. They are soft and can be cut with knife. Then they have low melting and boiling point compared to other metals, and they are good conductors of electricity. Then chemical properties is they all behave, they have similar chemical reactions. So they react with air and water vigorously. So that is that. So then back to this. So the answer comes from those physical and chemical properties. So francium, if you check the periodic table, or at least they tell you on the first line, say francium is in the same group as sodium. That means it is in group 1. So what is the property of francium? Possible property of francium. So can it be cut? It cannot be cut with a knife. Cannot be cut by a knife. Is it true or false? Sorry? Okay, so we take this out. It has poor electrical conductivity. Metals are good conductor of electricity, so down. So then we go back, then we have C and D, which is the chemical properties. Okay, so we revisit C and D. We go back to the chemical properties again. So the reactivity is high when you go down the group. You see, this francium is here. Then the kind of chemical reaction it has is this one. It reacts with cold water to form metal hydroxide and hydrogen gas. So francium at the bottom should have high reactivity. So the reaction should be fast. So if you know the possibility, whether out of the 3 options, not 4 options, if you can isolate 3 of them or identify 1 of them, then you'll be
Not A, not B, not D.
So it's not D. So it reacts very vigorously. It's not mildly. Yeah. So you arrive at your answer in this manner. Okay. So we have now cesium. And then again it says, cesium is a member of group 1 of the periodic table. Would you expect cesium to be metallic or non-metallic? That is part 1. Then they say explain your answer. It's metallic, but then to explain whether something is metal or not is not by the location of the metal. So you know the metals are like, how you know something is a metal is that it will react and give away 1 electron to form a positive ion, or it will give away 2 electrons to form a positive ion. An indication of something is metallic is that it gives away electrons to form positive ions. So in this case, cesium is considered metallic because it gives away 1 electron to form a Cs plus ion. You say it has 1 valence then it will lose one valence to form an ion with a charge of +1. So it is a metal. So whenever you have a question asking you for whether something is a metal, you will say that it is because it loses X number of electrons to form a positive ion. So the reverse is also true. Sometimes they'll ask you, explain whether element X is a non-metal, okay? So if it's a non-metal, they will say that it has 5 valence electrons, maybe, say, so it will take in 3 electrons to form an ion with a charge of -3. So it is a non-metal. The answer is like that. So this part is the kind of answer you will have to give if they ask whether it's a metal or it's a non-metal. Not by the location of the element in the periodic table. They are not expecting that. So part B, what is the formula of ion formed by cesium? I think I gave you the answer. Cesium, yes. Write the chemical formula of cesium sulfate. So now you have to recall the formula for the sulfate ion. Okay. Right. This question is also in, the answer to the question is also inside whatever I mentioned earlier. So there are two parts again. Is cesium more or less reactive than sodium? Part 1. Part 2, explain your answers. The reactivity. Some more. There's more to this. This part may need more depending on how many marks you are required, or depending on how many marks the teacher is going to give for this question. So let's say the explanation alone costs 2 marks. What are you going to give as an answer? Need help?
Yeah.
Okay. So let's go back to this. So let's go back to this. Why does the reactivity of alkali metals increase down the group? So they say elements in group 1 become more and more reactive down the group because as we go down the group, the element loses its valence electrons more readily to form a positive ion, because this is due to the size of the increase in size of the atomic radius. That means the atom becomes bigger. So here, so back to here, they say, is cesium more reactive or less reactive than sodium? So explain your answer. So you have to say that cesium is bigger atom, or it has a greater atomic radii. Okay. Then it loses valence electrons more readily than sodium to form a positive ion. So therefore, CS is a more reactive metal. If this is for explanation. If it's not an explanation question, they say state why cesium is more reactive than whatnot, right? Then you can say that because the reactivity of alkali metals increases as it goes down the group. That state, if it's explained, you have that whole lengthy answers. See, they say the reactivity increases down the group. The position of CS is below that of whatnot. This is more like a state answer. But if they ask you for 2 marks, 2 marks, 2 marks, 2 marks, please write something like that. Okay?
Yeah.
If they ask for a lot of marks, then you have to really explain. Okay, then this one, construct a chemical equation to represent the reaction between cesium and water. So I'll wait for you to write it. If you need help, right, the products of the reaction, you can find them in the slides as well, on previous pages. Metal plus water, cold water will give you an alkali plus hydrogen gas. So what is this? You fill up. Then after that, write down the formula and then you balance. Hydrogen gas is always diatomic. Then balance the equation. Is it balanced already? So there are 2 cesium here, 2 cesium here. Yeah, 2 hydrogen here, 1 oxygen here. Then over here, there's 2 oxygen, 2 hydrogen, and another 2 hydrogen here. Is it balanced?
That is 4 hydrogen.
So not balanced yet, huh? So what can you do? Okay. Describe how cesium reacts with water. I think it's also somewhere out there. It's also been mentioned, something similar has been mentioned. Some more? What other, because it's a describe you, it's pretty much what you can see. So a cesium reacting with water, what kind of observation can you make? Yeah, something like this, the observation description. So describe how cesium reacts with water. So it can, so you saw potassium, the last one that blew up, right? That was potassium. And why it blew up is because the hydrogen would burn in air and then it blew up. So that means, right, cesium is below potassium in the reactivity, in the table, in the periodic table, in the group. So cesium would actually react more vigorously than potassium. So you can even say that it reacts explosively. So cesium react with cold water explosively to produce an alkali, to produce cesium hydroxide and hydrogen gas. So you can also indicate that you see effervescence because hydrogen gas is being produced. Effervescence means bubbles. Something like that. So it's more violent and then it's more explosive. This is just a summary. The answer is just a summary. So you have to mention, if it's a description, you have to say what you see. So depending on how long it is, if it's a 2-mark question, you probably have to say whatever I said earlier. Okay. So vigorously is probably an understatement because potassium already blew up. Okay. How would you test for the gas that was being released in the reaction? So it's asking you, how do you test for hydrogen gas? A chapter before this. Probably last chapter, I think it's in acids. You talk about this, how to test for hydrogen gas. A lighted spleen. So what happens to the lighted spleen? Use the lighted spleen, then what happens? Okay. Yeah. The pop sound is heard when da 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 da. Yeah. Extinguishes with a pop sound. Actually, your answer is better.